All right, folks, we are back at Dad's card for weapons and examples. We're going to be using molecular scenes to determine the signs of delta H, S, and G. This question states the following scenes represent a familiar phase change for water, which is the blue spheres. As you can see, we have these water molecules that are moving, have a lot of freedom of motion, and then they have a decreased freedom of motion. This first letter is telling us what are the signs of delta H and delta S for this process we see here. Then they want us to explain. And then for letter B, it says, is the process spontaneous at all temperatures, no temperature, low temperature, or high temperature? And then it also wants us to explain. So again, we have to use the relationships we just saw between delta H, S, and temperature to help us figure out the spontaneity or the delta G value. Well, let's go ahead and start with letter A. They're asking us, what are the signs of delta H and delta S? So for letter A, the sign of delta H is going to be negative. Why? Because we're going from a gaseous state down to a liquid, we're going to be releasing heat. And therefore, the delta H value is going to be less than 0. So we have a negative value here. Now, for delta S, we have a decrease in the freedom of motion. A decrease in the freedom of motion, decreased microstates, and therefore a decrease in entropy. So a decrease in entropy means your delta S is going to be less than 0 or negative. From our delta H and our delta S being negative, we can use our relationships from before to help us answer letter B, which is the process spontaneous at all temperatures, no temperatures, low temperatures, or high temperatures? All right, so I brought back my trusty little table from our information before. We know that our delta H is negative and our delta S is negative. So when I look at my table, I'm going to find when they're both negative. Here we see that our term or our variable T delta S is going to be positive. So in order to figure out if delta G is going to be spontaneous or if this process here is spontaneous, we have to rely on temperature. As you can see, it's going to be spontaneous at lower temperatures. So if they ask me, is the process going to be spontaneous at all, no, or low, or high? We're going to choose low temperatures based on our table, and that will be our overall answer. Let's go ahead and look at another example in Dad's card. So here we're told to determine the effect of temperature on delta G. Question reads, a key step in the production of sulfuric acid is the oxidation of SO2 gas to SO3 gas. So you're going to start with the reaction 2SO2 plus O2 to form 2SO3. At 298 Kelvin, your delta G value for this overall process is negative 141.6. Automatically, I can tell you that we are spontaneous at this particular temperature. Next, they give us the values of delta H, which is negative, and delta S, which is also negative. They tell us, using the data they want us to use for letter A, the data to decide if this reaction is spontaneous at 25 degrees Celsius and predict how delta G will change with increasing temperature. Next, for letter B, they want us to assume delta H and delta S are constant. So we're going to use the same numbers that are given with increasing temperature, meaning no phase change occurs. Is the reaction spontaneous at 900 degrees Celsius? So again, they're asking us to kind of conceptually figure things out based on what's given, and then they're asking us to calculate at a new temperature and figure out if it's going to be spontaneous. So let's go ahead and get started with letter A. So first I go ahead and write my reaction. 2SO2 plus O2 is going to produce 2SO3. Then I write down what's given. Delta H is equal to negative 198.4 kilojoules. Then we have our delta S is negative 187.9 joules per Kelvin. And then our delta G is equal to negative 141.6 kilojoules at 298 Kelvin. I also write my expression for Gibbs free energy, which is delta G is equal to delta H minus T delta S. Now for letter A, they said use the data to decide if the reaction is spontaneous at 25 degrees Celsius. Now since we're using our expression, we know we got to get our temperature in Kelvin. So you add 273 to 25, you get 298 Kelvin. Well, we already said that since our delta G is negative and that's given, and they already told us it's going to be specifically at 298 Kelvin, then yes, this entire process or reaction is spontaneous at 25 degrees Celsius. Then it goes further and says, predict how delta G will change with increasing temperature. Well, if we continue to increase the temperature, that means we're going to continue to increase the temperature in our T delta S value. If we continue to increase this along with S being negative, then our term for delta or T delta S is going to become more positive. This value becomes more positive, delta G is still going to be negative, but it's just going to be less negative. So if it's less negative, that means it's going to be less spontaneous. Let's go ahead and move on to letter B. So for letter B, I'm still going to have my same reaction, and it says assume that delta H and delta S are constant with this increasing temperature. So that means delta H and delta S that were given are going to be the same. Then they're telling us that we're going to increase temperature for this reaction all the way up to 900 degrees Celsius. And if we increase the temperature up to 900 degrees Celsius, will this reaction be spontaneous? Well, we're going to increase our temperature to 900, so let's go ahead and convert it to Kelvin. Add 273 to 900, and you get 1173 Kelvin. Now, in order to figure out if we're going to have this reaction be spontaneous at this temperature, we have to solve for our delta G expression. So we know delta G is equal to delta H minus T delta S. We can plug in our value for delta H, that's given. We can plug in our value for T, which is 1173 that we just calculated. But for delta S, we must make sure that we are converting from joules to Kelvin to kilojoules per Kelvin. So we're going to take our delta S value, negative 187.9, and divide it by 1,000 joules. Now we get negative 0.1879 kilojoules per Kelvin. We can use that in our expression and calculate delta G. Whatever our delta G value is going to tell us if this reaction is spontaneous at that temperature. So if we have a negative delta G value, it's spontaneous. If we have a positive delta G value, it is non-spontaneous. So we're going to solve for delta G by plugging in our values. So our delta H is negative 198.4. We're going to subtract that by our temperature, which is 1173 Kelvin, multiplied by negative 0.1879 for our entropy. When we multiply these two numbers together, we get negative 220.4067 kilojoules. Of course, our kelvins are going to cancel out. Now, when we take our delta H and subtract it by our value here, I get 22.0 kilojoules. Because delta G is greater than 0, that means that this entire reaction is going to be non-spontaneous at 900 degrees Celsius. Okay, so using these new weapons gave a serious hit to the ghost. It's now stunned, folks, but the salt rounds are getting low. So what do we do next?